Greetings, my good people, and welcome again to Shani Grades Online School. Today, we take you through A.C.K Diocese of Mumias Chemistry PP1. Please, if you are new to this channel, find your time to subscribe to our YouTube channel and hit the notification button to be notified whenever we drop a video of this kind. Don't also forget to share this video to reach as many students as possible. Welcome. Question number 1. An element Y has the electron configuration 285. Identify its period. Students, given the electron arrangement or electron configuration being 285, it is very possible for us to identify the period of this particular element and as well identify the group of this particular element. While identifying the period, we consider the number of occupied energy levels, and we can see that we have 3 occupied energy levels, 285. All those energy levels are occupied, and therefore, for the period, it is in period 3. And we use numericals to identify the period. Therefore, the correct answer to this question is period 3. Is period 3. If it were for the group, then we could have used capital Roman numbers. And therefore, in our case here, it could have been group 5, using Roman capitals to identify the group. But in our case, our element Y was in period 3, using numericals to identify the period. Moving to question part B. Write a formula of the most stable ion formed when Y ionizes. Looking at this particular element with electron configuration of 285, it reacts by gaining 3 electrons. It will be very hard for this particular electron or element to react by losing the 5 electrons than gaining 3 electrons. Therefore, the most stable ion for this particular element, it shall be Y with a charge of 3 minus. This means it gains 3 electrons for it to be stable. Therefore, that is the correct answer for that particular question. Moving to part C of this question, explain the differences between the atomic radius of element Y and its ionic radius. Students, we need to understand that element Y is a non-metal. And being a non-metal, basically it's phosphorus. Being a non-metal, it reacts by gaining electrons. For non-metals, we know the ionic radius is always larger than the atomic radius. And this is because we have the already existing electrons and the incoming electrons that brings about repulsion. So that repulsive power, the repulsion that exists between the incoming electrons and the already existing electrons, makes the ion to appear larger than the atom. Therefore, giving the differences, we first state the differences and then we give an explanation. So we say its ionic radius is larger than its atomic radius. We use comparative term, larger. So we say its ionic radius is larger than its atomic radius. After stating the difference, then we give an explanation and we say this is because the incoming electrons, this is because the incoming electrons are repelled by the electrons already in the energy levels, by the electrons already in the energy levels. So the repulsion makes the ion to appear larger. The repulsion makes the ion to appear larger. So stating the difference 1 mark and giving the explanation 1 mark. Moving to the next question, question 2. The table below shows tests carried out on a sample of water and the results that were obtained. The first test, it was addition of sodium hydroxide solution. When it was added, white precipitate which dissolved in excess was noted or was formed. Students, this is analysis of salts, the qualitative analysis. Whenever we add a few drops of sodium hydroxide and then in excess, we always make observations. Addition of sodium hydroxide, in this case, we are not told whether it was in excess. It is just addition of sodium hydroxide and white precipitate which dissolves in excess was formed. And we know during adding sodium hydroxide, we always determine the presence of three cations, and we always call it ZAP. ZAP, Z representing zinc ions, A representing aluminium ions, and P representing lead-2 ions. Therefore, if this particular addition of sodium hydroxide led to a white precipitate that led or that dissolved in excess, then we cannot make a conclusion which cation was present in that particular solution. So we leave it at that point, and then we move to experiment or test 2, addition of excess aqueous ammonia. When excess aqueous ammonia was added, we know very well that we have 2 cations that dissolve in excess, and that is say ions, 2 ions, and we also have copper 2 ions. But we need to take note of copper 2 ions dissolves to form a deep blue solution. So if it forms a deep blue solution, we do not expect it to be one of the cations here because we are forming a colorless solution. So that substance that dissolved to form a colorless solution automatically becomes zinc ions. So we can conclude that in this particular solution, zinc ions were present. Therefore, aluminium and lead were not there. Then we move to test number 3, addition of dilute hydrochloric acid and barium chloride. We are adding barium followed by an acid, or acid followed by barium chloride. And whenever we add barium or lead chloride or lead nitrate, we always determine presence of certain anions. And we have 3 major anions that we determine. We have the sulfate ions, we have the sulfite ions, and we also have the carbonate ions. If I add the acid and barium chloride and then a white precipitate forms that dissolves in addition of the acid with effervescence taking place, then the ones with trace, the sulfite and the carbonate are present if it dissolves. But if I add the barium chloride and the acid and there is no effervescence or there is no bubbling, and at the same time a white precipitate is formed that does not dissolve, then the sulfate with 4 is present. So according to our test here, addition of dilute hydrochloric acid and barium chloride led to white precipitate, so it never dissolved. And this means that the sulfate ions were present. Therefore, learners, we can confidently answer the question after we have just given an analysis for the same. So let's move to first question, part A. Identify the anion present in water. We know, learners, that in a salt, in any given salt, for instance, if I have zinc sulfate, anion is the negative ion, the ion with the negative charge. Like in this case, we have the sulfate, and then zinc is the cation. So the anion is zinc ion is the cation, and then we have the sulfate being the anion. So the negative ion forms the anion. So we identify the anion. So in this case, sulfate, because we have been taught to identify the anion, then we can just write the formula like this. So because we are not taught to name, we are just taught to identify the anion. So it is sulfate ion 1 mark. Next question, write an ionic equation for the reaction in step 3. Step 3, that is where we were adding barium chloride. So we expect there to be a precipitation between the barium and the anion present in that particular solution. And we have just concluded that anion present in that given solution is sulfate. And therefore, we write the ionic equation. In this case, our ionic equation becomes barium ion, which is aqueous. Then we add the sulfate ion, which is also aqueous. And therefore, we form a precipitate, which is barium sulfate. And this is a solid. And therefore, students, this gives you 1 mark. Moving to question number 3. Solutions can be classified as acids, bases, or neutral. The table below shows solutions and their pH values. We have solution K against its pH 1.5, L 7, M 14. We know pH values ranging between 0.1 to 6.99. Those are acids. Then substances with pH value of 7, that is a neutral solution. Then substances from 7.1 all the way to 14, those gives us a base. So we remember we also have strength of these substances. We have strong acids and also weak acids, strong bases and also weak bases. So in this particular table, select any pair that would react to form a solution 7 with pH 7. Learners, we need to understand that it is only reactions that involves acids and bases that leads to formation of salts that are neutral. For instance, take an example of sodium hydroxide reacting with hydrochloric acid, giving us sodium chloride, and that is a neutral salt. Therefore, the pair that will give us a solution with pH of 7 is K and M. So we have K and M. Each have a mark, total 1 mark. Please note that it will only be a pair for you. It should always be a pair for you to be in a position to score a mark. You write K, then you get a 0 without M. You write M without K, then it becomes a 0. Please take note of that. Then let's move to part 2 of this particular question. Identify two solutions that would react with aluminium hydroxide. Explain. Two solutions that would react with aluminium hydroxide. In this case, we need to understand that aluminium hydroxide is one of the substances referred to as amphoteric substances. It is an amphoteric substance, aluminium hydroxide and also aluminium oxide, together with zinc oxide and lead oxide. These particular substances, they react with both acids and bases. And therefore, we are being taught to identify two solutions that would react with aluminium hydroxide. Therefore, we have K, which is an acid. At that time, if K reacts with aluminium hydroxide will react as a base. And if I choose M and I react with aluminium hydroxide, at that moment, aluminium hydroxide will be reacting as an acid. Therefore, if I were to choose two solutions that would react with aluminium hydroxide, then I will choose K and M once again. K and M. Therefore, to give an explanation, I'll say aluminium hydroxide is amphoteric. Aluminium hydroxide is amphoteric. This means that it can react with both acids and bases. Then as if you just write K, at least you may have a mark for the same. But remember, because the total marks that you are giving us is only one mark, meaning stating the two gives you a mark and the explanation gives you a mark. Therefore, there is need that you mention the two of them. Moving to part 4 of this paper, question number 4. State Graham's law of diffusion. State Graham's law of diffusion as learned in Form 3 in the topic gas laws. How does it state? Graham's law states that the rate of diffusion of a gas is inversely proportional to the square root of its density at constant temperature and pressure. So we say, states that the rate of diffusion of a gas, the rate of diffusion of a gas is inversely proportional to the square root of its density at constant temperature and pressure. So statement should be complete for you to score a mark. So we know that the rate of diffusion of a gas is inversely proportional to the square root of its density. And this is where we get the formulas that we use to work out rate of diffusion of gases or determine molecular masses when we are given the rate. Now, we have part B of this particular question. 60 cubic centimeters of oxygen gas diffused through a porous partition in 50 seconds. How long would it take for 60 cubic centimeters of sulfur oxide gas to diffuse through the same partition under the same conditions? Students, as you look at this particular question, you realize that the volumes of the gases were equal. Therefore, given the time for the first gas, the time taken for the first gas to diffuse through the partition, then we could just directly use the relationship that says that the time of oxygen, use the time of the first gas is oxygen. So we have time of oxygen over the time of sulfur peroxide is equivalent to the square root of the two. We have the square root of oxygen at the top and under the square root of sulfur peroxide. You need to understand that we are relating molecular mass with time. Therefore, when you are relating with time and molecular mass of each gas, they are placed on the same level. For instance, you can see time oxygen, molecular mass oxygen, all of them at the top. Then time sulfur oxide and molecular mass of sulfur oxide again, they are directly facing each other. Therefore, we just do the normal substitution. Given the time of oxygen as 50 over the unknown type of sulfur oxide, then we obtain the molecular mass of oxygen. If I try to work out the molecular mass of oxygen, then oxygen, the formula is O2, meaning I will take 16 multiplied by 2, and this gives me 32. For sulfur oxide, to determine the molecular mass, sulfur is 32, oxygen is 16 times 2, and the total gives me 64. So I'm going to have 32 divided by 64, not forgetting the square root sign. When I work it out, I'm going to have 50 out of time for sulfur oxide is equivalent to, when I do this 32 divided by 64, then I take the square root, I shall obtain 0.70707. Then I do the cross multiplication, whereby I'm going to have 0.70707 time of sulfur oxide is equals to 50. Then I divide this by 0.70707. I divide here by 0.70707. And when I work out time sulfur oxide would be equivalent to 70.71 seconds. These learners take note that if the volumes were not equal, then we could first equalize the volumes by asking ourselves if at 60 time is 50, then if this volume was 80, then we ask ourselves what about at 80, and then from there we proceed as normal. So this question, working out this 1 mark, this 1 mark, and answer 1 mark. Moving to the next question, question number 5. Study the flow chart below and answer the questions that follow. We have metal oxide. We have a non-metal, metal oxide. This metal oxide, ammonia was added unto it, and we obtained white precipitate X. Then excess ammonia was added to the white precipitate, and a colorless solution Y was obtained. As I said before, if I see a colorless solution by adding excess ammonia, automatically there is presence of zinc ions. It is only zinc that can dissolve in excess ammonia to give us a colorless solution. The other one is only copper, and copper gives us a deep blue solution. And if the cation present in this solution was zinc ions, then I can trace the oxide, and then the oxide becomes zinc oxide. The white precipitate, when we add a few drops of ammonia to a precipitate, we usually use the OH in ammonia, and this means that I'm going to obtain zinc hydroxide. So if I was to write the ionic equation that led to precipitate X, it is a metal oxide. So this metal oxide, we are going to obtain zinc ions aqueous reacting with a few drops of ammonia, and that is what led to the white precipitate zinc hydroxide, zinc 2 hydroxide. And I balance here with 2 to make it balanced. This is a solid and it's a white precipitate. So, to answer the question, identify the metal oxide, I've said that we are going to have zinc oxide. We have zinc oxide at this point here, zinc oxide. Still writing the name is correct, zinc oxide. These learners, if you cannot write correct formulas, then just give the full name, zinc oxide, and this gives you 1 mark. Write the ionic equation leading to the formation of precipitate X, and that is when now we write zinc ions aqueous reacting with hydroxyl ions from a few drops of ammonia, and this gives us zinc 2 hydroxide, and this is a solid, and we balance here with a 2. Again, this gives you 1 mark, having written all the state symbols correctly, and again writing the formulas correctly. Part C, give the formula of the ions responsible for the colorless solution. We know the ions that forms the colorless solution is due to the complex ions that are formed. So the complex ions is between zinc and 4 molecules of ammonia with a charge of 2 positive. Therefore, giving the formula, we shall have zinc tetraamine, zinc tetraamine or tetraamine zinc 2 ions. So this is 4, and then we have a charge of 2 positive. So that is the formula of the ions responsible for the colorless solution. We call it tetraamine zinc 2 ions. Tetraamine zinc 2 ions. Please, if you are not taught to name, do not give it a name. Question number 6. 2 compounds of barium are barium sulfide and barium chloride. Remember, it is also allowed to write sulfide like this. Sometimes we usually use sulfide this way. So it is also okay to use F to represent sulfide. So 2 compounds of barium are barium sulfide and barium chloride. Part A of this question, the hazard symbol shown in figure below is on bottles containing barium metal. So this state the meaning of this hazard symbol. When you see this kind of a symbol with a flame and another smaller flame within it, then this means flammable materials or flammable substances. So the meaning is flammable. This means the substances are flammable. So 1 mark. Part B of this question, give the names of the elements combined in barium sulfide. When you look at barium sulfide in Form 1, you are taught that whenever you find a compound that its name ends with IDE, that means the elements present in that particular compound. There are only two. And if that is the case, barium sulfide, we have those names that we can identify directly. We have barium and sulfur present in that particular substance. So we have barium and sulfur. So we have barium and sulfur. Please do not say barium and sulfide. Sulfide is the compound. For you to score, it is barium and sulfur, the original form of that element, sulfur. So each have a mark, total 1 mark. Part C of this given question, hydrogen sulfide gas is highly poisonous. State one safety precaution that should be taken when handling hydrogen sulfide. What are some of the precautions that you should take when you are handling this poisonous gas? One of the precautions, you should perform the experiment in open space or in a cupboard. Perform the experiment in an open space or cupboard. Precaution number 2, you wear protective gear, that is face mask. You can wear protective gear, for instance, face mask. Moving to question number 7. Study the information in the table and answer questions that follow. We have an isotope R1 and R2. The mass number of isotope R1 is 69 and the mass number of isotope R2 is 71. They have same number of atomic numbers of 31. Therefore, we also given their relative abundances in terms of percentages. For R1, 61.3 and for R2, 38.7. You can see that R1 is more abundant in that particular element. Part A of this question, determine the number of neutrons of R1. How do we determine the number of neutrons? We need to understand the structure of the atom very well and the principles that govern the structure of an atom. We know that mass number is given by the number of protons plus the number of neutrons. Atomic number represents the number of protons. If I say the atomic number was 31, then that means the number of protons were 31. So we are being taught to determine the neutrons in R1, and therefore, having the mass number as 69 is equivalent to P plus N, and my case, P is that 1 plus N, which is unknown. Then, mathematically, N becomes 69 minus 31, and therefore N is equivalent to 38. Part B of this question, calculate the relative atomic mass of element R. How do we determine a relative atomic mass given the percentage abundances? We know that relative atomic mass is given by mass of an isotope, multiplied by the percentage abundance. Then we divide by 100. In this case, because we're given percentages. But now, because we have two isotopes of R, we need to add the two for us to determine the relative mass. So in this case, I'm going to have relative mass is given by the mass of isotope 1, which is R1, is 69, multiply, that is the mass, multiply by its abundance, which is 61.3. That is specifically for the first isotope. Then plus the other isotope, which is 71, multiplied by its percentage abundance, that's 8.7. When I work this out, students, I obtain 4229.7 plus 2747.7, and then divided by the 100. The total becomes 6977.4, then divided by 100. And the relative mass becomes 69.774. So the relative mass is around 70, and remember, relative mass has no units. So this gives you 2 marks. Moving to question number 8. Identify the type of bond that forms the compound below. You can see that this is oxygen that bonds with hydrogen. And we know we use this to represent which type of bond. This is covalent bond. This is covalent bond. So the type of bond is covalent bond. Part B. Using dots and crosses to represent electrons, show bonding in magnesium oxide. So magnesium oxide, we need first to know how to write the formula of magnesium oxide. Magnesium and oxygen bonds forming ionic bond, whereby we know there is complete transfer of electrons from one element to the other. And therefore, without wasting much time, we know magnesium reacts by losing 2 electrons, and we know oxygen in number 8 reacts by gaining 2 electrons. Magnesium loses 2, oxygen gains the 2. Therefore, using crosses and dots, we can represent this. So I'm going to have magnesium. Then I have 2 energy levels, because after losing the 2, I'm left with 2 energy levels. So I'll use process for magnesium. So I have 1, 2, then 1, 2, 3, 4, 5, 6, 7, 8. And after doing that, remember this one is an ion. So I have to write it as an ion with a 2 positive, and this is magnesium ion 2, 8. Then closely, I have the one 4, oxygen. Oxygen, in the case of oxygen, I use dots so that I can easily show the electrons that were gained from magnesium. So again, I'm going to have 2 energy levels. So I already have 6. But now the 2 will come from magnesium element or atom. and therefore I'm going to have 2 negative, and it is oxygen ion, which is 2, 8 again. Please make sure that this bond is not far away from the 2 atoms are not far away from each other. They are a bit close so that the bond can be identified easily. So this gives you 2 marks. Question number 9. Show the products formed when the following salts are heated by writing a balanced chemical equation. You need to remember the effect of heat on salts. The first one represents the effect of heat on nitrates. So here we have potassium nitrate. Potassium nitrate is being decomposed by heat, and when it is decomposed, we know nitrates, when they are applied, or when heat is applied to nitrates of more reactive metals, we always obtain the nitrite and oxygen of that particular metal. So in this case, we are going to have, or to obtain, potassium nitrate, which is a solid, and at the same time we collect oxygen gas. Balance the equation by putting a 2 at this point and a 2 at this point, and the equation balances out. Then for the ammonium carbonate is affected by it and leads to formation of 2 gases, ammonia gas, carbon 4, and water. So in this case, I obtain ammonia gas, carbon dioxide, and water. I balance the equation by putting a 2 at this point to make the equation balanced. So completing and ensuring the equation is balanced, you get 1 mark each. Moving to question number 10. Explain why, when one is struck by a bee, application of a little solution of sodium hydrogen carbonate helps to relieve the pain. This is the issue of acid and bases. We know the stalk of a bee contains an acid. That acid, applying sodium hydrogen carbonate, which is a base, it gets neutralized. And therefore, we say a bee stick produces an acidic substance. A bee stick produces an acidic substance, and application of sodium hydrogen carbonate, which is a base, and application of sodium hydrogen carbonate, which is a base, neutralizes the acidic or the acid from the bee sting. Neutralizes the acid from the bee sting. And that gives you 2 marks. So mentioning the issue of an acid in the bee sting, I have a mark. Mentioning the issue of sodium carbonate being a base, I have a mark. And talking about the issue of neutralizing the acid, 1 mark. And that gives you 2 marks. Question number 11. The following table gives the melting point of oxides of the 3rd period elements. Study it and answer the questions that follow. We have the formula of oxides. We have the sodium oxide. We have magnesium oxide. aluminium oxide, silicon oxide, we also have phosphorus oxide, and sulfur oxide. We have the melting point of sodium oxide being 1190 degrees Celsius, magnesium being 3080, aluminium being 3050, silicon being 1730, phosphorus being 560, and sulfur oxide being negative 73. You can easily tell that metals have highest boiling melting points as compared to gases or non-metals. Silicon oxide is a special case with a bit high melting point. When you look at the melting point of silicon oxide to that of sodium oxide, you notice that sodium oxide has a lower melting point. And why this? We know silicon oxide has giant covalent structure, which requires high temperatures to break the bonds between the molecules, therefore high melting point. Sulfur oxide, you can see it as a negative melting point, meaning gases being molecular, they require very little temperature to break the bonds. Let's look at part A of this question. Explain the large difference in the melting points of sodium oxide and phosphorus oxide. Why this difference? So we say sodium oxide has a giant ionic structure. We know metals have giant ionic structures, and they also have metallic bonds. And when you look at the case of phosphorus oxide, they have molecular or simple molecular structures, and those bonds require very little energy to break. Therefore, we say sodium oxide has a giant ionic structure, with strong metallic. In this case, it is a compound, so with strong ionic bonds, which need large amounts of heat to break, which require large amounts of heat to break. And if I compare it now with phosphorus, we say which have large amount of heat to break, hence high melting point. Then on the side of phosphorus oxide has covalent bonds with simple molecular structure, requiring less amount of heat, and hence lower melting point. So stating the difference correctly gives you a total of 2 marks. Part B of this question. Write the equation for the reaction between aluminium oxide with sodium hydroxide. In this case, aluminium oxide is reacting as an acid. Remember, we said aluminium oxide is an amphoteric substance. So the reaction leads to formation of a salt and water. So when I react sodium hydroxide, in this case aqueous, plus aluminium oxide solid, I obtain sodium aluminium oxide or sodium aluminate, which is aqueous, it's a complex salt. Then I also obtain water, which is liquid. I balance the equation by putting a 2 on sodium and also a 2 on sodium aluminate. And in this case, here aluminium is reacting as an acid. Then I write the equation when it is reacting with aluminium hydrochloric acid, and I'm going to have aluminium oxide, which is a solid, reacting with hydrochloric acid aqueous, and I obtain salt, which is aluminium chloride, and which is aqueous, and water. In this case, aluminium oxide is reacting as a base. I balance with 6 on hydrochloric acid. I balance with 2 on aluminium chloride, and I balance with 3 on water. And this, in this case, aluminium oxide is reacting as a base. Moving to part or question number 12. A hydrocarbon slowly decolorizes bromine in presence of sunlight, but does not decolorize acidified potassium manganate 7. Name and draw the structural formula of the fourth member of the series to which the hydrocarbon belongs. Students, we need to understand that among the 3 hydrocarbons that we know, that is alkenes, and alkynes, we have alkenes and alkynes being in a position to decolorize potassium manganate 7 because they have the double and triple bonds respectively. Alkenes have no capacity to decolorize this oxidizing agent, but it can decolorize bromine water simply because alkenes, they also have capacity to react with halogens. So you'll find a case where we react, for instance, methane with aqueous bromine. So in this case, it is going to decolorize this particular solution because we can see substitution reaction will take place in this kind of a reaction. So it is only alkanes that have ability to decolorize alkanes, to decolorize bromine, but they cannot decolorize strong oxidizing agents such as potassium manganate 7. But for alkenes and alkynes, they can decolorize all of them. They can decolorize alkenes. Alkenes can decolorize bromine water. It can also decolorize acidified potassium manganate 7. And therefore, this one that had ability to decolorize bromine water but was not able to decolorize acidified potassium manganate 7, it should be an alkane. And therefore, in that series of alkanes, we want to draw the structural formula for the fourth member. The fourth member under the alkanes is always butane. Therefore, butane, having the structure of butane, we are going to have 4 carbons. So it is 1, 2, 3, 4. Because we are being taught to draw the structure, we are not just going to write the formula. So we balance the bonds. So here we need 3, here 2, here we need 2 to make it 4, here we need 3 to make it 4. And that is the structural formula. So because we're being told name and show the structure, so in this case it is butane. It is butane. Giving a name 1 mark and drawing it another 1 mark, and that totals to 2 marks. Question number 13. Distinguish between ionization energy and electron affinity. What's the difference between these two? What's the meaning of ionization energy? Ionization energy is the minimum energy that is required to remove an electron from the outermost energy level in gaseous state, while electron affinity is the energy released when an electron is added to a gaseous atom, or we can say is the energy released when an atom gains an electron in the gaseous state. So we say ionization energy is the minimum energy required to remove an electron from the outermost energy level, in gaseous state, while electron affinity is the energy released when an atom gains an electron, in the gaseous state. So that particular atom that is gaining an electron should be in gaseous state. That's the difference between ionization energy and electron affinity. Giving correct difference gives you 2 marks. Question number 14. The setup below was used to prepare a carbon dioxide gas. You can see the setup. We have a flat-bottomed flask. We have calcium carbonate, and we have a non-substance A. Then we have incomplete delivery tube that should be inserted in another medium. So we begin by trying to remember what we learned in Form 3, that is Form 2, on preparation of carbon dioxide. Carbon dioxide, we said, can be prepared by reacting acids, dilute acid, and appropriate carbonate. And the most appropriate carbonate that we settled on was calcium carbonate, or what we call the marble chips. And we reacted it with dilute hydrochloric acid. And then we passed the collected gas through a base or an alkaline solution, which was sodium hydroxide or sodium hydrogen carbonate. and then later it was tried through concentrated sulfuric 6 acid, and then the gas was collected using downward delivery because the gas is denser than air. And therefore, if that is the case, we give the formula the name of substance A. Substance A is dilute hydrochloric acid. This is supposed to be dilute hydrochloric acid. Complete the diagram to show how the dry gas can be collected. So I've said the first stage we pass this gas through a conical flask that contains sodium hydrogen carbonate. So inside this I put sodium hydrogen carbonate solution. Allow me to use formulas, but in your case use the name sodium hydrogen carbonate solution. Then from there I pass the gas through another conical flask that contains concentrated sulfuric 6 acid. So I have concentrated sulfuric 6 acid So this is concentrated sulfuric 6 acid. Again, allow me to use formulas. And then lastly, I collect my gas using downward delivery method. So I collect my gas using downward delivery method. And this becomes carbon dioxide gas. This is cardboard. This is delivery tube. And please, learners, take note of the tubes. The delivery tube should be fully inserted into the solution, but the one that is coming out should be on top of the solution. It should not be inserted into the solution. The one that is taking out the gas. So when you look at this particular delivery tube, it is not inserted into the solution, but the one that is bringing that gas is fully inserted into the solutions, and therefore that should be taken note of whenever you are doing these kind of diagrams or setups. The one that is bringing the gas should be fully inserted into the solution, but the one that is taking the gas outside should be a bit above the solution. And therefore, having that gives you 2 marks. We have the marks for workability. Do not leave gaps in between your apparatus so that you score the half mark for workability. Some cases, if you don't know the method that you may use and you are collecting a dry gas, you can use a syringe to collect that gas. That will save you from getting a 0 in that particular question. Always, if you are not sure whether it is downward delivery or upward delivery, use a syringe to collect that particular gas. Let's move to the next question, part C. Write the equation for the reaction. What happens here? We have calcium carbonate reacting with dilute hydrochloric acid. Therefore, the equation becomes calcium carbonate is, in our case here, we are given calcium carbonate as a solution, but supposed to be a solid. Then we react with HCl, which is a gas, which is aqueous, and we obtain salt water and carbon dioxide. In our case, our salt becomes calcium chloride. Not forgetting the issue of valencies. Calcium chloride is soluble in water, and therefore it is aqueous. Then plus water, which is liquid, plus carbon or oxide gas. Balance the equation. When you look at the equation, it is balanced. Calcium 1, carbon 1, carbon 1, oxygen 3, oxygen 3, hydrogen 1, hydrogen. We have hydrogen 1, hydrogen 1. So we put a 2 on hydrochloric acid, and then we have hydrogen 2, hydrogen 2, chlorine 2, chlorine 2, and the equation becomes balanced, and therefore this is 1 mark. Moving to question number 15. Calculate the mass of sulfur which on complete combustion would yield 7 liters of sulfur oxide measured at 182 degrees Celsius and 722 millimeter mercury pressure, given the relative atomic masses of oxygen 16, sulfur 32, and molar gas volume maintained at 24 liters at room temperature and pressure. So when you look at this question, you realize that this is a question on combined gas laws, whereby we use the formula P1 V1 over T1 is equals to P2 V2 over T2. This particular gas, we are given the values of this gas, the volume, the pressure, and the time, that is, and the temperature, and then we are told to determine time, that is the temperature of this particular or the volume when maintained at room temperature and pressure. Therefore, using whatever we are given in this question, we have P1, our P, we are going to use P2, we have P1, let's arrange them, P1, V1, T1, then you have P2, V2, T2. So what we have? We are being told to calculate the mass. So we'll first determine the volume. Once we get the volume, then we can proceed on determining the mass. So calculate the mass of sulfur which on complete combustion would yield 7 liters of sulfur oxide measured at 182 degrees Celsius, 722 millimeter of mercury pressure. So we are going to begin by stating or substituting this equation. Our P1 is 722, the one that we are given, 722. Our V1 is 7 liters. Our T1 is 182 degrees Celsius. But remember, we shall add 273. Our P2 at room temperature and pressure is maintained, or the pressure that we use there is 760 millimeter of mercury. Our V2 is what we are looking for. And our T2 is 25 degrees Celsius. So it is 25 plus 273. So when I try to work this out, I will take 760 multiplied by V2 that we do not have is equals to 722 multiplied by V1 that we have 7. Then we divide here by 298, that is the T1. And on this side we have 455, which we get from 182 plus 273. When I work out this, I will obtain 4.4 liters. 4.4 liters. But remember, our question says determine the mass. So when you look at this particular equation, we have sulfur solid reacting with oxygen, a gas, to give us sulfur oxide gas. We are determining the mass of sulfur as solid. When you look at the mole ratio, you realize that it's 1:1. The mole ratio for sulfur 4 that you are determining the volume, and this, the one for sulfur is 1. Again, 1:1. So using the volume that we have determined for sulfur oxide that maintained at RTP, we can determine the moles of sulfur that was used. So in this case, if it is 1:1, then I will determine the moles by first determine the moles of sulfur oxide by saying that using the molar gas volume is 24 liters, and this is always maintained. This is always for 1 mole. So I'll ask myself if 1 mole of this gas is 24 liters. The one that is at molar gas volume is 24 liters. What about my 4.4? When I work out this, I'm going to have 1 times 4.4 and divide by 24. When I work out this, I'll get 0.18 moles. So these moles, because the mole ratio is 1:1, then it will be equivalent to the moles of sulfur. So how will I determine now the mass? I know the mass of sulfur is 32. So mass of sulfur will be given by moles times molar mass. So which is 0.018 multiplied by its molar mass, which is 32. And when I work out this, I will be able to obtain that we are working out for me to work it out. I have 0.18. I multiply by that 2 the mass becomes 5.76 grams. 5.76 grams. That is the correct answer to this particular question. Let's move to question number 16. From two students from Achiever Secondary School reacted 3 elements as shown in the table. We have elements X, Y, and Z, the reaction with oxygen and the reaction with water. X, reaction with oxygen forms acidic oxide and it do not react with water. While reacting with oxygen, it formed basic oxide. It formed basic oxide. Z, and reacting with water, it forms soluble hydroxide that gave off hydrogen gas. And Z formed acidic oxide with oxygen and dissolved to form an acidic solution. So we can make a breakdown here. This is an element reacting with oxygen, it gives an acidic oxide. So we can say this is an oxide of a non-metal. Reaction with water, no reaction. So that metal does not react because we are looking at elements reacting with, not the oxide, the element reacting with water, no reaction. So this is a non-metal that do not react with water. It's a non-metal that again do not react with water. While formed a basic oxide, so this is an oxide of a metal. So Y is a metal. It formed a soluble hydroxide and gave off hydrogen gas. That is when I take the metal, I react with water, it gives me a metal hydroxide with a release of a gas. So this means when Y is reacted with water, it reacted to form an hydroxide, assuming it was in valence 1, and it released hydrogen gas. Z formed acidic oxide. This is for a non-metal because they form acidic oxides. Dissolved to form acidic solution again. This, it must be a soluble gas, not a because we are dealing with the element. So when this element reacted with water, it dissolved to form an acidic solution, not the oxide, the element reacted with water to form an acidic solution. So in this case, it must be a soluble gas. So this gas may be a chlorine reacting in water to form an acidic solution. That is the interpretation that we can make in this given question. Let's try to answer these questions. Which element or elements is likely to be a non-metal? So from the information that we are given, X and Z, they are likely to be non-metals. So we have X and Z. Which one is likely to be a metal? We have seen forming basic oxide, so it is Y. Which one is likely to be insoluble in water? We have seen that Y, X, no reaction. So if there is no reaction, automatically it is not soluble in water, and therefore it is X. So here, first one, 1 mark, half for each. This one, 1 mark, this one, half, 1 mark. Let's move to question number 17. A polymer has the following structure. Look at the structure of the polymer. A sample of this polymer is found to have a molecular mass of 5194. Determine the number of monomers of the polymer given the relative atomic masses for hydrogen 1, carbon 12, nitrogen 14. So we need to understand this particular polymer. This polymer, you can see the repeated sections of it. You can see the repeated section of it so that we be in a position to obtain the monomer of the cell. So when you look at it, the monomer becomes CH2, a double bond, CH, then Cn. So this is the monomer for this particular polymer. So how do we determine the number of monomers in a particular polymer? Number of monomers is given by molecular mass of the polymer divided by the relative molecular mass of the polymer. So according to what we are given here, we are given 5194 as the relative molecular mass of the polymer. And we can easily determine the molecular mass of the monomer because we already have the relative masses here. In this case, we have 2 carbons. For 3 carbons, we have 3 carbons because we have 1, 2, and then 3. So we have 12 times 3, then plus hydrogens are 3, 1 times 3, then plus 1n 14. When we work this out, we obtain 53. So that is the molecular mass for the monomer. So I divide by 53. When I divide this, I will obtain 98. So the number of monomers are 98. So we have 98 monomers. So 1 mark. Determining this, I have a mark. And answer, I have a mark. Learners, formulas have no marks. Please take note of that. A formula will add you marks when you write it correctly. Substitute it and you get a correct answer. Question number 18. State the likely products of electrolysis of molten potassium chloride at the cathode. Learners, in Form 4 you learned on under the electrolysis, preferential discharge of ions, and you learned electrolysis of molten solutions and also electrolysis of aqueous solutions, considering certain factors for the discharge of the ions. In our case here, we have molten potassium chloride. Potassium chloride, like in the case of the mercury cell, you know very well this one being a molten solution. We have potassium ion and we also have chloride ion. On top of this, we have hydrogen ions and we also have hydroxyl ions. So when I look at what is going to be or to move to the cathode, I expect the positives to move to the cathode, and the positives include potassium ion and hydrogen ion. And we say for the electrolysis of molten substances, it will be hard for us to discharge hydrogen because discharge of hydrogen will require a lot of energy and as compared to potassium. So under normal condition and considering the position of hydrogen in the electrochemical cell to that of potassium, we could have discharged hydrogen. But in our case, we are saying that we not discharge hydrogen because it requires a lot of energy for it to be discharged. So in this case, we are going to say we are going to discharge potassium at the cathode. So state the likely product of electrolysis of molten product of potassium chloride at the cathode. So we are not being taught to identify the ion. We are taught to state the likely product. So if we discharge potassium ion, we'll gain electron and we shall form potassium solution, liquid, or potassium metal. So state the likely product. So potassium metal. So in this case, the answer is potassium. Potassium. At the anode, we expect chloride, and we also expect hydroxide to be discharged. But we say hydroxide should have been discharged, but now because molten solution is a highly concentrated solution, we discharge chloride ions because of their high concentration. So in this case, if we discharge chloride ions, we expect these to lose electrons and form chlorine gas and discharge an electron. We balance with 2 and with 2 here. Remember, when writing this ionic equation, we always start with the anode, so this means that this one could have been 2, 2, and 2. So the product that could have been formed on the anode or at the anode, it is supposed to be chlorine. Supposed to be chlorine. The one it's supposed to be have a mark. So we have a mark for potassium and have a mark for chlorine. Part B of this question. Write the equations that occur at the anode and cathode. How do we write equations at the cathode and anode? We have just said that when writing these equations, it's good that we start with the equation at the anode. We have said that at the anode, we have chloride ions being discharged at the expense of hydroxyl ions because of their high concentration. Therefore, the equation is chloride ions, aqueous, not forgetting the state symbols, losing electrons to obtain chlorine gas, and then with a discharge of an electron. As we try to look at this equation, it's not balanced, so we try to balance with a 2, and this shows that we discharge 2 electrons, and therefore we balance with a 2. At the cathode, we discharge potassium ions at the expense of hydrogen ions. Therefore, we are going to have potassium ions, aqueous, plus or gains an electron to form potassium solid. Because we lost 2 electrons, those 2 electrons must be gained at the cathode. And this is 1 mark, and this is 1 mark. Question number 19. Give 2 reasons why helium is used in weather balloons. Why do we use helium in weather balloons? Helium, one of the reasons why it is used in weather balloons, it is less dense than air. It is less dense than air. It is also chemically unreactive, or we say it is inert. It is chemically unreactive. Say it is inert. And we can also say it is not flammable. unlike hydrogen. Remember, hydrogen was also used in air balloons, so it is unflammable. Unlike hydrogen. So any 2 gives you 2 marks. Question number 20. A Bunsen burner produces a yellow flame when air hole is closed. Explain. So we know the type of flame that is produced when the air hole is closed is luminous flame. So why does the Bunsen burner produce a yellow flame when that air hole is closed? So we say the closure of air hole leads to insufficient supply of air. Closure of air hole leads to insufficient supply of air, ends in complete combustion of the laboratory gas, ends in complete combustion of the gas, of the burning gases. Say the gas because it's only one of the gas. So we can add and say the incomplete combustion of the gas produces tiny carbon particles which glow yellow when heated. The incomplete combustion of the gas leads to production of tiny carbon particles which glow yellow when heated, and this is how luminous flame becomes yellow, simply because the air hole is closed. Let's move to question 21. In an experiment, a boiling tube full of chlorine gas was imparted into a trap of water as shown below. State and explain the observation made. So when we invert a boiling tube that is containing chlorine, we expect first the chlorine to dissolve in the solution in that water to form chlorine water. This chlorine water contains hypochlorous acid. Hypochlorous acid, or we call chloric 1 acid, it's affected by light, so it decomposes in presence of light, producing an oxygen, and that oxygen, it leads to water in the beaker rising up and water in the boiling tube dropping to accommodate that gas. And therefore, the observation that we make is the level of water in the boiling tube reduces. The level of water in the boiling tube reduces. Then we can explain and say, chloric 1 acid present in chlorine water decomposes. Chloric one acid present in chlorine water decomposes in sunlight producing oxygen. In sunlight producing oxygen, which displaces the water in the boiling tube. Students, we can still say that there is the chlorine water fades out. Remember, we expect to see a yellow-green color of the chlorine water, so we expect that color to disappear. That might also be an observation. So explaining this gives you 2 marks. Part B of this question. And before we proceed, we have said that when chlorine gas dissolves in water, it leads to formation of chlorine water. So this chlorine water is a mixture of 2 acids, hydrochloric acid and hypochlorous acid. Hypochloric 1 acid, chloric 1 acid. And when this chloric 1 acid decomposes in the presence of sunlight, it breaks down into hydrochloric acid and it produces the oxygen. And that's how the color of chlorine water changes. And again, oxygen displaces the water in the boiling tube to be accommodated. Part B of this question, if the experiment is repeated with tetrachloromethane instead of water, state the observations made. So the question is, if we pass a chlorine gas in tetrachloromethane, what will be the observations that are going to be made? We need to understand that chlorine or water is a polar solvent. Tetrachloromethane is a non-polar solvent. So if I pass this particular gas through tetrachloromethane, I might not necessarily make an observation. One, I will not be able to see the color of chloric 1 or chlorine water, that is yellow green. And again, I will not be able to see the gas being collected. Therefore, we can say no gas will be collected in the boiling tube. That is one of the observations. No gas will be collected in the boiling tube. And the reason as to why the gas will not be collected is because it will not dissolve to form the 2 acids or to form chlorine water. Explain your observations in B Roman 1 above. So we say chlorine dissolves in tetrachloromethane, but it remains in molecular form, and therefore there is no what we call chloric 1 acid formed, which is the source of oxygen that is formed in the boiling tube. So we say chlorine dissolves in tetrachloromethane but remains in molecular form. Remains in molecular form. That's no chloric 1 acid that forms, which is the source of oxygen or the gas. And this gives you 1 mark. Question number 23. Study the flow chart below and answer the questions that follow. We have sodium propanoate and we have substance W. And when these two react, we expect them to give us a then and another substance Y. Students, we need to understand that this is basically preparation of alkanes. And we know that we prepare alkanes by reacting soda lime with an appropriate metal alkanoate or sodium alkanoate. If I want to prepare methane, then we know we use the preceding alkanoate or the alkanoate of the preceding alkane. If I want to prepare methane, then I would use sodium ethanoate. If I want to prepare ethane, I'll use sodium propanoate. If I want to prepare pentane, I'll use sodium hexanoate. Therefore, before us we have substance W, and because we have said that we use appropriate sodium alkanoate and we have it here, sodium propanoate, substance W automatically becomes soda lime. Learners or students, remember that soda lime is a mixture of sodium hydroxide and calcium oxide. When the two react, they lead to formation of the key product, which is the alkane and sodium carbonate. So automatically Y becomes sodium carbonate. So we can easily answer the question now. Name substance is W. Substance W is soda lime. I've said that this soda lime is a mixture of sodium hydroxide and calcium oxide. Y, we have said that Y is the second product after the two reacts to give you the alkane, and the second product is always sodium carbonate. Remember, we have been taught to name, not give a formula. So it is sodium carbonate in words, sodium carbonate. And again, this is our mark and this is our mark. Part B of this question, an organic compound K reacted with bromine to form 2,3-dibromobutane. Draw the structural formula of K. So we have been taught that an organic compound K reacted with bromine to form 2,3-dibromobutane. Draw the structural formula of K. So how does K look like? Because before it reacted with bromine, it was a certain compound. Now before we obtained 2,3-dibromobutane. So this K, we need to obtain its formula. So K, it could have been an alkane. And this alkane, it must have reacted through addition reaction. And if we can form 2, 3, then it means it looked like this. 1, 2, 3, 4. So it was an alkene, it was butane. So the double bond was here, and that's where the reaction occurred to form 2, 3. So this means these were hydrogens initially. Please do not overcrowd the bonds. Suppose every carbon should have a maximum of 4 bonds. So that is how organic compound K looked like before it reacted with bromine. So we are told to draw the structural formula of K, and that is K. Supposed to be but 2 in, but 2 in, and that is the formula. Question number 24. Starting with copper metal, describe how a solid sample of copper 2 carbonate can be prepared. Students, we have two options or two alternative methods of preparing copper 2 carbonate. We know copper itself do not react with dilute acids. One of the methods that you can use is to react copper with concentrated nitric 5 acid with excess copper. This is to obtain a filtrate of copper to nitrate that we then react with a soluble carbonate. And then we shall be in a position to prepare copper to carbonate. That is method 1. Then method 2, we can have the method of first burning copper to obtain copper 2 oxide. And after obtaining copper 2 oxide, we react it with dilute warm sulfuric 6 acid, where we then obtain copper sulfate. And then this copper sulfate, we can now react with excess sodium carbonate to obtain copper 2 carbonate. So let's use the one for fast burning copper to obtain copper 2 oxide. So we say heat copper metal, heat copper metal in excess air, to obtain copper 2 oxide. Then add excess copper 2 oxide to dilute sulfuric 6 acid. Please use words, don't use formulas as I do. To dilute sulfuric 6 acid and warm. Filter to remove unreacted copper 2 oxide. Filter to remove unreacted copper 2 oxide and add excess sodium carbonate. Sodium carbonate solution. You are doing this to the filtrate. Then allow it to react. Give it enough time to react, the filtrate, and allow it to react. Then after doing that, filter to obtain copper 2 carbonate. Filter to obtain copper 2 carbonate as residue. Then after obtaining the residue, rinse the residue. Rinse the residue with water. and dry in between filter papers, and dry in between filter papers. So that is how you are supposed to write for the method 2. We have said that you can still react copper with concentrated nitric 5 acid to first obtain copper 2 nitrate, and then from there you look for an appropriate soluble carbonate to do the precipitation, and then you end up collecting copper 2 carbonate. Writing this gives you 3 marks. Question number 25. Study the information in the table below and answer the questions that follow. The letters do not represent the actual symbols of the elements. We have element, we have electrical conductivity, we have ductility, and we have action of water. Element A is a good electrical conductor. It's a good ductile properties or ductility properties, and it do not react with water. Please take note of that. It has good electrical conductivity, it has good ductility, and it do not react with water. We have B with good electrical conductivity, poor ductility, and no reaction with water. C, good conductivity, good ductility, and react with water. So we are supposed to select element which is likely to be in group 2 of the periodic table. Group 2 are metals, and we know that they are good conductors of electricity, and they are good conductors of electricity, and they do react with water, metals. Therefore, the most likely element is supposed to be C, unlike A and B. A has good ductility, good conductivity, but no reaction with water, and that makes it to be eliminated. For B, could select an element which is or could be used to make electric cables. So which one is likely used to make electric cables? Electric cables, remember, we could not like them to react with water. What we need is them to just conduct electricity and be in a position to be able to be drawn into wires. And therefore, the most suitable is A, which is a good conductor of electricity, and it is a good ductility. It has good ductility. Therefore, the most appropriate in this case is A. Which one is likely to be graphite? Graphite, it do not react with water, and again, it do not have ductility. We know metals are they are ductile and malleable, but for these non-metals like graphite, they are not ductile, and therefore the most appropriate becomes B. Moving to the next question, question number 26. In an experiment or investigation, sulfur oxide gas was bubbled through acidified bromine water. This was followed by drops of barium nitrate solution. State the property of sulfur oxide under investigation. So, we need to understand that when I have sulfur oxide and I react it with bromine water in this case, a gas having been passed in water, that gives us bromine water. And in this case, we are told that we have sulfuric 6 acid, and we have what we call hydrobromic acid or hydrogen bromide. When you look at this, we are told that sulfur oxide gas was passed through acidified bromine water. This is our bromine water. And this was followed by drops of barium nitrate solution. Still the property that was under investigation here. The property that was being investigated is a reducing property. At long last, we expect the bromine water to decolorize because sulfur oxide is oxidized to sulfuric 6 acid as bromine water is reduced to hydrobromic acid, which is hydrogen bromide. So there is reducing property of sulfur oxide, which is under investigation. So it is a reducing agent, it's a reducing property. State the observations that were made on addition of sulfur oxide into the bromine water. We expect the color to change to colorless because bromine water is orange in color. Therefore, we expect it to decolorize. So we say sulfur oxide, bromine, yellow bromine water is colorized. Yellow bromine water, or we can say orange bromine water sometimes. But let's use yellow. Most of the times we use yellow. Yellow bromine water is decolorized. 1 mark. Explain the observation. Why did it decolorize? We have said that there is a redox reaction occurring simultaneously. There is a reduction oxidation reaction taking place. So we say sulfur oxide reduces bromine water to colorless hydrobromic acid. Sulfur oxide gas reduces bromine water to colorless hydrobromic acid. Hydrobromic acid, while itself is oxidized to sulfuric 6 acid. While itself is oxidized to sulfuric 6 acid. This explanation gives you 1 mark. Question number 27. Study the flow chart below and answer the questions that follow. We have ammonia reacted with a certain gas in presence of platinum. Probably a catalyst to give us nitrogen 2 oxide. Then nitrogen 2 oxide is added to oxygen and it gives us nitrogen 4 oxide, and then nitrogen 4 oxide is added, is passed through water, and it gives us G and J, which are all solutions. And students, you can easily notice that this is manufacture of nitric 5 acid, large scale manufacture of nitric 5 acid. And we begin with ammonia. Ammonia reacted with oxygen. So in this case, this is oxygen gas in presence of platinum catalyst to give us nitrogen 2 oxide. Nitrogen 2 oxide is then reacted with oxygen to give us, we have nitrogen 2 oxide, is 4. We have nitrogen 2 oxide reacted with oxygen to give us nitrogen 4 oxide. And then nitrogen 4 oxide is reacted with water. And as we know, we always obtain 2 acids, nitrous acid and nitric 5 acid. And that's where we have G and J. So identify gas X. Gas X is oxygen gas. Is oxygen. One will mark. Write an equation for the reaction between ammonia and gas X. So that is ammonia and oxygen. When ammonia reacts with oxygen, the two are gases. We formed nitrogen 2, which is the gas, and we also obtain water in form of vapor or gas. I balance the equation by putting a 4 on ammonia, putting a 3 on oxygen, we have oxygen, we have put a 2, we put a 4 on nitrogen, then for 4, nitrogen becomes 12, so nitrogen will also make it to be 12 by putting a 2, oxygen 4, 10, so I balance the oxygen by putting a 5, and the equation becomes balanced. Moving to the next question, part C. Write an equation to show the formation of G and J. We have already done it. So formation of G and J is by reacting nitrogen 4, which is a gas, with water. So we pass this gas through water, and we obtain a mixture of two acids, which is nitrous or nitric 3 acid and nitric 5 acid. All of them are aqueous solutions. The equation is balanced by putting a 2 on nitric 5 nitrogen 4 oxide, and when you look at it, it becomes balanced. Nitrogen 2, nitrogen on the other side are 2, oxygens are 3, we have oxygens 4 plus 1, 5, then we have 2 plus 3, 5, hydrogen we have 2, 2, and the equation is balanced, so we put, this question gives you 1 mark. Question number 28, define pollution. What is pollution? We refer to pollution as the contamination of the environment with harmful substances that cause undesirable changes to the natural environment, and this may harm the living organisms. So it just say is the contamination of the environment with harmful substances. Is the contamination of the environment with harmful substances that may cause undesirable changes to the environment and harm living organisms and harm living organisms. This gives you 1 mark. Mention one pollutant that is a particle. You have many forms of pollutants. Most of them are in form of particles. For instance, carbon, lead, dust particles. So we may have carbon, dust, lead. Anyone will give you have a mark. Which one A pollutant that is gaseous form can talk about the greenhouse gases, the sulfur peroxide. Remember, we have been taught to mentioning. I'll focus on the name. So I'll mention sulfur peroxide. I can also mention hydrogen sulfide. I may also mention carbon 2 oxide, nitrogen 4 oxide, those gases which pollute the environment. Question number 29. Hydrogen gas was burnt in air to form a colorless liquid. Describe a chemical test to identify the colorless liquid. So when we burn hydrogen in air, we expect it to form water. So we are being taught to describe a chemical test to identify the colorless liquid. Remember, we have the physical methods of boiling it, and we have the chemical methods of, we have physical, maybe we can freeze, we can boil it and determine the boiling point. And then we have the chemical method that we can use chemicals such as anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride. So in my case, I'll use anhydrous copper 2 sulfate. So I'll say add the liquid to anhydrous copper 2 sulfate. If anhydrous copper 2 sulfate changes from white to blue, if anhydrous copper 2 sulfate changes from white to blue, hydrated copper 2 sulfate then the substance shall have been tested. So if anhydrous copper 2 sulfate changes from white to blue, then the colorless liquid is present. You can still use anhydrous cobalt 2 chloride, which changes from blue to pink. So this explanation gives you 2 marks. Part B of this question, state how the purity of the colorless liquid can be determined. How can we determine the purity? Purity, we use freezing point or the boiling point. So we freeze the liquid. If it freezes at 0 degrees Celsius, then it is pure. You can still boil the liquid. If it boils at 100 degrees Celsius at sea level, above sea level, then it is pure. So we can do any of these options. You can say freeze the liquid and determine its freezing point. If it freezes at 0 degrees Celsius, then the colorless liquid is pure. You can still do the one for boiling. If it boils at 100 degrees Celsius, then it is pure. My dear friends, my dear students, this marks the end of our today's presentation. If you found this particular presentation helpful to you, please find your time to like this video, share it to at least 10 students whom you think may need this kind of explanation. And as well, comment your reactions at the comment section. Mention the type of paper that you'd like us to revise in our coming days or the coming days. You can also comment what you think should be improved in our presentation, but try to be as positive as possible. Otherwise, we thank you for your continuous support. May you keep on watching our videos, keep on subscribing. For those who have not subscribed, make sure you subscribe and hit the the notification button for you to be notified whenever we drop a video of this kind. And most importantly, we would like to take this chance to wish this year's candidates, the Form 4, all the best in their upcoming examination. Believe and you're going to perform. Keep on revising, and you're going to get the grade of your choice. God bless you. May we meet in our next presentation. Thank you.